Hi everyone, hope you are doing fine. So again today I am going to solve the uh, daily lead code challenge problem, and after that I am going to solve the contest that happened yesterday. Let's start with the daily challenge problem. So the problem name is remove covered intervals. So in this problem we are given a integer array like array intervals where intervals li, ri represent the intervals li represent the interval LII removes all intervals that are covered by another interval in a list. Like the interval AV is covered by interval CD if only C is greater than equal to A and D is greater than equal to. Return the number of remaining intervals. So yeah, so so what we have given in this problem is like we have given a different type of intervals. Yeah, but like let's take this example. So we have something like the interval, and let's say we have let's define the number line. It looks something like 1 2 3 4 5 6 7 and 8. So we firstly we have something like one like a range from 1 to 4, then we have something like 3 to 6, and then another we have something like 2 comma 8. So yeah, so you can see like we can only merge two like we have to remove the interval only if the a comma b completely lies inside c comma d. So you can see uh does an interval lies between 1 comma 4? No, I think no. Some interval lies between 3 comma 6. No, but you can see like in 2 comma 8, this 3 comma 6 lies completely inside 2 comma 8, so we can simply remove this thing. So yeah, so the simple approach is the first approach that came minded by reading this problem is like what we can do, we can simply loop through all we can check whether this can be removed, 1 4 can be removed, 1 4 can be removed, so we can compare with all other pairs. So yeah, if it can remove 1 4 can't be removed, so yeah, again we check with 3 6. So 3 6 we check with firstly no need to check with yeah, we also need to check with the previous thing also. So we can check can 1 4 a 3 6 lies completely inside 1 4? No. Then we check with 2 8. Yeah, so you can see 3 6 completely lies between range 2 to 8, so we can simply remove this thing. Then we left with 2 8. Now let's check with 2 8. Can 2 8 completely lies inside 1 4? No. So this is already removed. No need for no need to check for this. Yeah. Then again, like this, we so we are not able to remove this thing. So yeah, in this answer we have after that we get our answer, like we have two that intervals. So we have to simply return that. So yeah, so as the constraints of problem are quite low, it's 1,000 only. So this approach will also work. So yeah, let's write this write the code for this approach, and after that what we are going to solve it for higher constraints. Let's say if the problem constraints were up to 10 to 5 or up to 10 to 6. So yeah, let's firstly write the code. So we can taking the size of the array, and we can say we are maintaining a dp or simply maintaining a state whether it is removed or not. By one it mean if the value of dp is at an index it is 1, it means that we have already removed this interval. Yeah, and we also maintain the count of number of interval we have already removed. So yeah, so we can check from j equal to 0, j less than and j plus plus. Can this interval be removed? So how we can check? So if So let me wait for a minute. So yeah, so now we have to check if this this I interval lies in B interval. So for that we can check if the v of I comma 0 must be greater than equal to v of j comma 0, and the last value like v of I comma 1 must be less than equal to v of j comma 1. So yeah, if it mean that it's completely lies inside this, so we can make dp of I equal to 1. So we have already removed this pair. So yeah, and we can also increase its count plus. So yeah, after that we can simply return n minus count. So yeah, let's try to run this. Mm, so it should be I plus plus. So we are getting answer as 1. So after that, like if we have we can remove this, we can simply break the loop. But again we are getting a 0. uh, yeah, for interval itself, it should be in a range, in range. So we can do like if I equal to j, like if the the interval we are checking and the interval we are taking to comparing is same, then we can simply skip that case. Yeah, now let's try. I think it should now work. Let's see. Yeah, it's working. So let's try to submit this. So yeah, you can see this is working, but like I think it's a easy problem. So yeah, let's make the constraint up to 10 raised to power 5 and try to solve this thing. So like in this, we are checking for every pair. So can we do something better? How we can do? So let's say we have something like pair like this. We can simply make some pair and then we'll try to solve this thing. 6 comma 9, 8 comma 14, and yeah. Yeah, I think this example is good to go. And we can simply take 5 comma 12 also. And yeah, I think, yeah. So now firstly, what we are doing, I am thinking of, so we can simply try to sort on the basis of start time. So if we sort by the, we can say the start interval. So it will look something like this. And for the ending time, we are going to sort with the maximum value first. So it will look something like 1 comma 8. Then we will have something like 1 comma 4. Then we will have something like 2 comma 3. Yeah, we can say then we have something like 2 comma 3. 2 comma 3, I think we have something like then 5 comma 12, and then we have something like 6 comma 9 and 8 comma 14. Say, yeah. So what we can do, we have something like this. So we can simply check like whether we can take this or not. So how we can do this thing? So let's say for this 1 comma 8. So like you can see like if the values are sorted by the first value in like increasing order and second by decreasing order. So you may, like if some index is starting at start is I, then if the any other value that starting at I is like its end must be always be less than this. So it means that like if we 1 8 can like 1 8 can cover all the other thing which are going to start with like 1 for sure. It like for this we are guaranteed. So it means that 1 4 lies in this thing, so we remove this thing. Then again we check the second one. So yeah, like you like we have to only check with the end time because the start time will always be in a range. So yeah, you can see like 2 3 also come in this range. Then again we will check what is our like we can say end time. So you can see that in this the end time is 12. So now our end time was 8. So we can increase our end time to 12. So it will look something like 5 comma 12. So yeah, we know that like every starting like starting will be greater or it's me or it like is going to be equal. So yeah, so let's say now check for this like 6 comma 9 also lies in this. So we only check with last value like 12 is greater than 9. So yeah, it lies inside. So again we check with 14. So you can see the and is greater than 8 this. So it means that it can't cover this thing and we are going to update it with 8 comma 14. So at last we can see we was able to remove these three, 1 2 and 3. So yeah, I think this approach will work. So what I am trying to do, so firstly I am doing like a sorting. First thing is like I am sort on basis of the first value like a start, and like this sort like we this is going to be increasing order and this is going to be decreasing order. So after that what we are checking I am going to take the like and value, and like if the next and is greater than this and I am going to increase my like remove count, and else I like if it is greater I am going to update my and with that value and again checking for the whole array. So yeah, let's write the code for thing this thing. So what we have to do like firstly we have to like we don't need this thing in. So yeah, firstly we need to sort this array. So yeah, we are going to create this like a comparator function. So yeah, this comparator function is used to like sort the array with our custom like values, we can say like that like we can sort the array according to our choice. So like so what we want like we want a of 0 value must be less than b of 0, but what we want in case of same like if the a of 0 value is equal to b b of 0 b of 0 in that case we need a of 1 must be greater than b of 1. So yeah, so this is the simple thing. So we can simply sort the array now, v dot begin comma v dot and we can simply pass our custom comparator function. So once the array is sorted, now we are going to maintain our int like int and is going to be a v of I comma we can say like a v of 0 comma 1, and our count will be a 0 initially. So now we can simply check from I equal to 2 and up to n, and we are going to increase our count and we can check like if the n is greater than or equal to v of I comma we can say yeah 1. So it means that we are going to increase the count, and else what we are going to else and is going to be a v of I comma 1, we can say. Like if it does not lie, it means that the and is going to like v of I comma 1 is greater. So in that case we are going to like update our value, and last we are going to return and minus count. So yeah, let's try to run this. Wow. We are get so sorry, it is a b. So we are getting output as 3, and it must be a 2. So yeah, let's print out our sorted array and see in which what order it is giving us the answer. So it must be a V, and for auto. So it's giving in a correct order. Yeah, I think. So we get like you can see, it must give a 1 answer. Sorry. So we have to start I from 1, not 2. So yeah, that was a mistake. I think now it should work. So yeah, it is working fine. So let's try to submit this. So yeah, today problem was quite easy. So yeah, let's see like I have already solved the problem. So let's see. Yeah, I solved it in 2022, and let's see which approach I followed that time. So and this what I am doing. Firstly I am sorting the array. Yeah, and then I am doing the a value and a b value, and if the a is equal to -1 and b is equal to -1, I am continuing. Uh, so yeah, so like I am doing the same thing that we do in first approach, but what I am doing, like instead of maintaining another array, I am making the value of v of like that value -1 if I have already taken that. So and I am doing size minus count. So yeah, I think the same approach why which we solved in first try. So yeah, let's now move to the contest part and solve the contest. So let's start the virtual contest. So the first problem is sum of integer with the maximum digit range. So you are given an integer array nums and digit, we can say nums, integer array nums, and the digit range of an array is defined as the difference between its largest digits and the smallest digit. For example, the digit range of 5724 is like 7 minus 2 is going to be a 5. Yeah, return the sum of all the integers in nums whose digit range is equal to maximum digit range among. So yeah, the problem is quite easy. Like so we have something given a array like this. So firstly we have to calculate, we can say, the digit sum. So what is a like a digit sum, like what is the difference between, you can see like the digit range is of an integer defines the difference between the largest and the smallest. Like what is the, like in 5724, the largest digit is 7 and the smallest is 2. So the digit difference is going to be a 5. So yeah, so we have to check for every number, like if you can see like in this case it is going to be a 0, we can say. Yeah, and in this case it is going to 5, and in this case also 5. So like we have to check for the maximum one. Firstly we have to calculate the maximum one, and then we have to check like who have maximum digit we can say what are digit range. We have to count the sum, like so in this case the answer will going to be a 5724 plus 350. That is going to be like we can say 6074. Yeah, so it's a quite easy problem. So I equal to 0, I less than n, I plus plus. We can say int n is going to be a v dot size, and in temp is going to be a, we can say, uh can a value be a 0? No, the value can be in a range like 10 to 10 is to 5, and the nums without length is 100 only. So it's going to be a, we can say, a temp is going to be v of I, and we can do simply a while temp is greater than 0, int val is going to be a temp modulo like a last digit, we can say last digit last digit is going to be this, and after that we can simply do a temp divide by 10. So yeah, so after that like mean value is going to be a mean of last digit, comma, we can say mean value, and the max value is going to be a max of last, we can say, yeah, last digit, comma, max value, and in it we can declare the max value as, we can say max value as 0, and the int min value as 1 is 6, because the value or less than, yeah, we can also define it as a 10 only, because the value are going to be in a range from 0 to 9. So yeah, so like in difference is going to be, we can say, difference is going to be a, what is the difference? So the difference can only up to 5, sorry, 9 only. So difference is going to be a max value minus min value, and we can simply make like a difference plus equal to, yeah, we can say a difference plus equal to, we can say v of I, and at last we can simply return the dp of diff, or we can say max diff. So we can simply here define the max diff is going to be a 0 initially, and we can say we have something like a dp of, we can say up to 10, or we can say up to 11 comma 0. So yeah, that's it. I think it should work. So let's try. So yeah, the syntax error. Syntax error again. So yeah, indifference, like indifference is going to be a, and a max difference is going to be a max of max difference comma difference. 6074 and 990. So yeah, let's try to submit this. So yeah, this is working. So let's move to the next problem. Subsequence after one replacement. So you are given a two string s and t consisting of lowercase English letter, and you may choose at most one index in s and replace the character at that index with any lowercase English letter. Return true if it is possible to make s a subsequence of t, otherwise return false. So let's see what are the constraints of problem. So it's up to 10 to the 5. So the problem is quite like a we can say straightforward. So in this problem we have given us two string s and t, and we can choose at most one index s, and replace the character at that index with any lowercase English letter. So return true if s is a subsequence of uh we can say a t. So in this, like firstly c a t or and a subsequence is a string that can be formed from another string by deleting some or no character without changing the order of remaining characters. So yeah, so let's take the example. So we have something like cat and something like chat. So yeah, we can check like if c matches, yeah, match. Now for this like a match, a don't match, so we can move to then so we can skip this thing and we can take this, and then again t matches and t matches. So yeah, so if that was the case, if we have to don't change any value, then it's a simple subsequence match problem. Like we can simply check like if it's going to a same, then we have we have only one option, we can take that thing. And if it's not same, then we can simply move to the next character, we can say next letter. Yeah, so how we can do something like so that the max value so our like we can what time so our we can at most take one thing, like at most one. At most one. So I am thinking of like a splitting the problem into two half, like something like that. So let's write some a bigger test case. We can say something like C A B D E. So let's write a random character F E A. So yeah, so now we have to make something like C. We can say B, and we have something like D comma E comma L comma A F E A. So we have something like this. So this is our S and this is our T. So what I am thinking, so what we can do, we can split, like you can see we can change at most one value, like let's say this is the like in this case this is a value which, so we can split the problem into two phase, like two part. Like we can check for whether we this part is possible, and like we can skip this thing and we can check whether this part is possible. If this is true and if this is true, if these both cases are true, it means that for this it is we can change at most one character, we can change it to any character, like we can say we can change it to so like in this case I think it is not going to be possible because we have to match something. You are replace the character at any index with any lowercase English letter. So yeah, so let's say here are something value like p. So you can say like now we can simply replace this L to a P. So so it will look something like C B D E P A F E A. So you can see like this is now this is a subsequence of this string T. So now the problem is converted into a different problem where we have to check for every subsequence, like whether the left part is subsequence and the right part is subsequence for that case. Like if we are taking for this, we have to check if we are taking first if we have to check from all I to like I to n, and we like if we are taking this thing, this c, then we have to check in whether like this part, if it is like this part is a subsequence, like c b d e l a f c a. So we have to check if this part is a subsequence. So how we can do this in a like optimized way? So I think we can do something like we pre-compute something like both from a left and a right side. So how we can are going to do this? So Let me zoom out this thing and define this thing. So yeah, so we are going to take two something like a two different array. Yeah, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So yeah. So firstly, so we need something like this. So yeah. So for we compare this C with this C. So yeah, these are matched. So it means that this subsequence, like sorry, we need to make for this thing. So let's write it below. C B D E L A F C A. So what I am trying to do, I am trying to do like if I am taking this subsequence at what index of this T it is going to be AND. So yeah, so let's say like for this C and C are going to be the same. This C and C is going to be the same. So at 0 index we get this thing, and then we compare C. We move to next index about this thing. So now we compare this B with A. So it is not matched. So we move this to next index in this T. So yeah, so this B matches. So it ends at we can say 2 index. Then again we move to 1 by index. This and this B sorry D and D matches, and then here will be and at this 3 index, like this subsequence and at 3 index. Then E and E also matches this in the at 4. After that like L, so there is no L. So yeah, so after that this is going to be a we can say infinity, or this is also going to be like we can say yeah, we can define it as infinity for now. Infinity, infinity, and infinity. So again same thing we do for do from right side, like so like this thing A and A going to match. Let's say this is going to be a yeah. So from this how we can check going to take this thing. So yeah, we are going to take this as a like an what is an I think 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 like 9. So then this E matches is going to be 8. Then it's FF matches, it's going to 7. Then this AA matches 6. After that there is no match, like you can see like this P come and there is no P, like sorry, this L come and there is no L in this. So it is going to be infinity, infinity. So now I am checking like if I can if I can take this like if I am going to change this character, can my next will be it is like this subsequence is possible. So you can see like if I am going to take this, if is it possible. So yeah, you can see like this value is infinity, so it is not possible to take this like this sub we can say for this sub array of this so yeah, it is not possible. So now let's move to B. So for B we have to check like whether this is possible and also this is possible. So for to check this we can check its previous value. Yeah, this and that 0. And for this we can say this B, so B and at infinity, so that it means that for this sorry D and at infinity, so it is not possible. Again we move to next, 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 and whenever we reach this L, you can see for for its previous value E it is and at 4, and for its next value it's and at 6. So it means that like if this value is going to be less than this value, it means that the subsequence is possible. If it is going to be like there may be case like something like that we can say cat yeah we have something like what example CFAT, like CFAF, and we have something like C A and F. So yeah, we have some t like something like this and s as this. So for this, if we make the prefix first from left array, so it is going to be a 0. For this it is going to be a like a 0 1 2 0 1 2 3, so it is going to be a 2. So yeah, you can see like this c and f can be formed as subsequence by taking this c and this f. So for this it is going to be infinity, and this is also going to be infinity. So now let's start from the right side. If we start from the right side, uh this f is going to be matched, so it is going to be a 2. And after that a is also going to match, so it is going to be a 1. After that is going to be infinity. So oh yeah, after that is going to be infinity because f don't match. So like if you can see, like if we replace this character a with any character of our choice, let's say we are changing this, and we have to check whether the left and the right part of this matches. So you can see that this also end at 2, and this also start at 2, like start at 2. So like this mean there is a overlap. So it's like cf is possible, and af is also like a we are taking like f is also possible. So but you can say, but these are going to be overlap thing. These are going to overlap, or and also we have to check like a difference between these two are going to be at least 1, because we have to also place this value now. Yeah, we are changing this, so we have to place this thing also. So the difference is going to be a greater than or equal to 1. So I hope you understand now. So yeah, let's write the code for this. uh, so firstly we have something like int n equals to s dot size, and int t is going to be a t dot size. So firstly we have to make a pre-computation from the left side. We can say for infinity we can do like something like infinity, uh, using infinity as 1e9 we can say. So yeah, so we can iterate from I equal to 1 and I less than n and I plus plus. So yeah, and int j is going to be a 0. So like if the s of I value is going to be a t of I value, it means that the both value are matched. And if the value are matched, then we are going to make the left of I is going to be a, sorry, left of I is going to be a j. And after that we are going to do j plus plus. Yeah, so that's it. And because I is going to be plus plus, yeah, and we have to check whether like until j is less than m, so it's going to be m. So if the j is less than m, and like a t of j is not equal to s of I, then we have to do j plus plus. And at any moment if j is greater than equal to m, we can simply break this thing, because like we have already leased the like n like last index of the t, so it is not for the like later on value it's going to be infinity. So similarly we can simply declare a vector or like a right vector, its value also going to be infinity. And then we like we have j equal to n minus 1 we can say, and we start from I equal to n minus 1 and I greater than equal to j, and we do minus minus. And while we can check like while j is greater than equal to 0, and like t of I is not like t of I is oh sorry, it is going to be a s of I is not equal to t of j, then we have to do j minus minus. And we can check if j is less than 0, we can simply break. And if not, so yeah, so we can simply remove this condition also, because it's going to be a same. And then we can do right of I is going to be a right of I is going to be a do j, sorry, j, and we do j plus plus. Yeah. So after that, we are going to traverse from I to n, and we are going to do I plus plus. So we have to check for like if the I equal to 0, or else if I equal to like n minus 1, and else. So like in case of I equal to 0, there is no left part, and in case of I equal to 1, there is no right part. So we have to handle that case specially, and as we have both left and the right part. So in that case, like in the left is going to what is the left part? Left part is going to be a dp of I, and the right part sorry, right part, like it is going to be I minus 1, and the right part is going to be a dp of, we can say, I plus 1. So yeah, so if left is not equal to infinity, and the right uh, is not going to infinity, so like if the both value are not going to infinity, and the left plus 1, left plus 1 less than right. So here I am checking like if the difference between like if the like if the first value is 4, another value must be 6. So I am checking that thing, because it can't be a 5, because we have to change that character ith. So yeah, if that is the condition, then we can simply return true, else we can continue. And now in case of I equal to 0, we can check like if the dp of I plus 1 is not going to be infinity, like if it is not infinity, and dp of I plus 1 is going to be we can say greater than, sorry, it is not going to be dp, it is going to be left, and the right part, we can say, yeah, so we can say it going to be a left value and the right value. So if the left value is not equal to infinity, and the right value is not equal to, and the left value plus right value. So yeah, I think so if the dp of I plus 1, sorry, not dp, so if left of I plus 1 is not equal to infinity, and the left of I plus 1 is greater than, we can say, greater than or equal to 1, so it means that it is possible. Similarly for this part, if we are at like and, we can say if the right of I, so like if for this is going to be a right, because we are at 0 index, so we have to check in left, and if we are at n minus 1, we have to check in a right. If the I minus 1 is not going to be infinity, and we can say left of I minus 1 is greater than, so less than equal to, we can say n minus we can say less than n minus 1. In that case, it is going to be a true, return true. So I hope this should work. So yeah, let's try to run this code. So we can do something like simply write 1 2 3 4 5 6 7 8. I think it should. Are we? So we can simply define as simply using define infinity. So it's going to be something like this. Yeah. So we have some, what are the error? Yeah. So let's try to redefinition of the J. Here we are defining J again, and J equal to 0. Oh, sorry. So yeah, we are defining again. So we can simply assign the value n minus 1, and it's going to be a left off, we can say. So for this, it is giving a false answer for both cases. So yeah, let's try to debug this thing. We are going to print our left and the right array. See. So in case of right, it is like you can see C start at 0, yeah, 0, and A match at 2 and T match at 3. So yeah, this part is correct. And but the we can see, but I think if we at I equal to n minus 1 must be less than, and the left of I minus 1 is less than n, like n minus 1, we can say. Yeah. So it is going to be m minus 1, not n, because the size of the T array is m. So let's try to run this. So yeah, we are getting true for this and a false for this, which is true. But why this is infinity? Yeah. J is n minus 1. J is greater than 0 and S of I is equal to T of J. So yeah, these both are equal. If the both are equal, then we can say this condition will work. And we do oh sorry, we have to do J minus minus here also. But again, this is not working. Why? So let's see out this thing also. So I am doing I equal to n minus 1. Yeah. So J is going to be, sorry, m minus 1, not I. So now I think it should work. So you can see like, uh, yeah, it's working fine. So let's try to submit this out and see if it is passing all the test cases or not. I think it should work. Mhm. So yeah, so we miss this thing, like if the size of the array is only 1. If the size of the array is 1, we can simply change the value and we can simply return, like if n is going to be a like if n is going to 1, then we have to simply return, we can simply return true, like whether the m can be, yeah, so it must be at least 1 also. And another case is like if the n dot, like if n is greater than m, it is not possible, so in that case we can simply return false. So yeah, let's try to submit now. So yeah, it's working. So so this was an interesting problem. So yeah, that's why it has, I think, the 5 point for the second problem. So let's move to the third one. So this is a like a divisible game. So you are given an integer array nums of length, we can say of length n, and Alice and Bobs are playing a game. Alice choose an integer k such that k is greater than 1, and two integer L and R such that L must be less than L and R must less than N. So Alice and Bob's playing a game. Alice and Bob are playing a game. Alice choose an integer k such that k is greater than 1. So k must be greater than 1, and two integer and L and R that must less than N. k 1 greater than 1 and L and R must less than n. Initially, both Alice and Bob's scores are 0. For each index I in the range L to R inclusive, if nums of I is divisible by k, Alice score increased by nums of I, otherwise Bob's score increased by nums of I. The score difference is Alice score minus Bob's score. Alice want to maximize the score difference. So like Alice want to increase its score. So if there are multiple values of k that achieve the maximum score difference, she choose the smaller such k. Return the maximum score difference, product of maximum score difference and the chosen value k such that result can be large. Constraints are pretty low, like 1000 only, and the nums of value is 6, 10 to 6. So yeah. So I so let's write this problem firstly in by the way let's so firstly like we have something like integer k. I'll choose some integer k, random integer k that must be greater than 1, and two integer l and r, l comma r. So initially both Alice and Bob score is 0 for each index I in the range L and R inclusive. If nums of I is divisible by k, Alice score increase by, so Alice score will increase by nums of I only if it is divisible by k, divisible by k, like divisible by k in range, like range L to R. If the I is in range L to R and it is divisible by k, it's going to be Alice score. Otherwise, Bob's score will increase by nums of I. So as we can say Bob's score increase by nums of I. So the score difference is like we want to maximize this value, like we want to increase them as much value as for Alice and like as low as possible for Bob. So Alice want to maximize the score. So Alice want to maximize the score difference. If there are multiple values of k that achieve the maximum score difference, she choose the smallest k. So return the product of maximum score difference. Return the product of return the product of maximum score difference. Return the product of maximum score difference. Product, what do you mean by product of maximum score difference and the chosen value k? So yeah, so the answer is going to be something like the maximum product of k, like we the value we are choosing the k, and we can say the difference we get, like a difference we get k into difference, that should be a maximize, like this we have to maximize this value k into difference. So let's take this problem to better understand the problem. So we have something like 1 4 6 8 and a k is 2 and I is 1, like k is 2, k is 2, k is 2 and like all the values are divisible by 2, we can say, yeah. So it is going to be a like 18. The sum of these like all going to Alice, and multiply k is 2, so like 18 into 2 is going to be 36. So it's quite simple, like we are taking the whole. So let's take another example like 212. So in this the Alice is going to take we can say, let's say k is going to be a, again k is going to be a 2. So Alice will get this thing and this thing. It is going to be 8 into 2 we can say 16. Oh, sorry. So 2 plus 2 is going to be 4, and Bob can choose one, so the value is going to be a 3. 3 into like k value is going to be a 6. So yeah, so we have to do this thing. So like you can see the range is very very small, like we can say 1000. So we will try to check for every like value, but there can be a possibility like a range problem, like a range there can be a multiple range from L to R. How we can do, like if we have multiple L and R can be of, there can be a multiple value of L and R. So like this nums of I is 10 raised to power 6. The one thing one optimization I am thinking of is like this can be up to a 10, nums of I can be up to 10 raised to power 6. So we can say like a v of I value is going to be a 10 raised to power 6. But you can see like if we do something like a modulo, it can be only divide by its half of the number, like up to 10 raised to power 3. Because if like you can see like 10 raised to power 3 can completely divide 10 raised to power 6, like if the number is greater that is greater than 10 raised to power 3, like we can say uh 1001, like it can't divide like a number like lesser than 10 raised to power 6. So this range is also going to be 10 raised to power 3, and for that the size of the array is going to 10 raised to power 6. So we can do something like we can do this loop, but the again problem is that how we are going to check for every range, like this L and R can be a very huge number, like not huge very, but we can say like a range can be a like if we have something like what is the example, first example we take 1468, like yeah, like you can see like for 1468 we have lot of option. Let's say we are fixing the k is like k is only from 1 to 1000 only. So let's say we are checking for k equal to 2. So for we have something like this option. Firstly, we have something like one this option. Then we have this. Again, from here we can have to do this. So like we have to do loop inside, which is going to be 10 raised to power 3 into 10 raised to power 3 for that loop, and for that k also it is going to be 10 raised to power 3. So it is going to be 10 raised to power 9. So which will not pass. But I think we can write code for that. So after that we get some like idea from that how the answer is calculated, and we can do some optimization. But let me think of something else. Can we like I think we can do some pre-computation type thing. So yeah, let me think of that. K can be 2. So yeah, so it's a simple like we have like this problem can be simply converted into like we have to find the maximum subarrayism, we can say like that kind of problem. So let's try it for example of a 2. So for the case of 2 let's take it for a case of 2, yeah. So 2 is not divisible by 1, so it is going to be a, we can say, -1. So 2 is divisible by 4, it is going to be a +4. Like sorry, 4 is divisible by 2, it is going to be +4. 6 is divisible by 2, it is going to be +6. 8 is divisible by we can say 8 is divisible by 2, it is going to be +8. So now we have to find a maximum subarray sum. like the maximum subarrangement, like which is going to be this. In this case, 4 plus 6 plus 8. What is this? It is going to be a, we can say 18. Yeah, 18. And then 18 into 2 is going to be a like 36. So yeah, I think we come up with the approach. So yeah, let me try to test for another case. I think it should work. Let's try it for 2 1 2. So we have something like 2 1 and 2. So let's say we are trying it for 2, like k. So we are trying for k equals to 2. So yeah, you can see like this is divisible by 2, so it is going to be plus 2, and this is going to be a minus 1, like not divisible by 2, and this is going to be divisible by 2. So like for this the maximum subarray is going to be a 3. Yeah, and 3 into 2 is going to be a 6. So for this the 6 is answer. Like we have to try it for multiple things, like from k equal to 1 to n, but for this now we are getting this. So yeah, so I think let's try to write the code for this also. So I think that the main observation was that, that this can be converted into a maximum subarray sum type problem. So n is going to be a v of size, and then what we have to do, firstly the k can be up to, from k equal to, we can say 1, k less than equal to, we can do it for 1000 for all the cases. And after that we have to do for I equal to 0, I less than, and I plus plus. So yeah, so we have something like we can say the new t array of size n, and like if the v of I modulo k equals to 0, it means that t of I is equal to plus v of I. Can value be an active? No, yeah, value can't be an active. So else it is going to be a t of I is going to be a minus v of I. Yeah, I think it's done. And after that we can simply pre-compute like a maximum subarray sum int I equal to we can say, yeah, I 0, I less than n, I plus plus, int like max sum, like we can simply take it as a yeah, we have to take like we have to take for int difference, like we have to return it modulo hashtag define l equal to long, and we can say hashtag define 1 0 3 3 4 5 6 7 8 and 9. Yeah, so we can say we have something like answer, it is going to be initially 0, and we can say ll sum is going, initially sum is also going to be a 0, and then we do something like sum plus equal to v of I, and ll max sum is going to be initially 0, and like if at any moment if sum less than 0, if at any moment sum is less than 0, k must be greater than 1, so k can't be at 2, so we have to do here k greater than 2, and l and r can be up from 0 to r, so we have to take at least one length subarray, so the answer can be a negative also. So we can do something like int min, and something like int min we can say uh, if sum is less than 0, like we can do simply like max sum is going to be a max of answer comma max sum, and if the sum is less than 0, so then sum is going to be again sum, we can mark it as a 0. So yeah, we are done with this. So now we have to check like if the like temporary answer is going to be, we can say, max sum into k. If the answer is like if temp answer is greater than our actual answer, then answer is going to be a temporary answer, yeah. And then we can simply return answer. So let's try to run this. uh, so it is going to be a mod. So at last we have to return answer modulo mod. 000. Wow, that's nice. So let's try to print this sum and max sum, and we can increase this value or decrease this value to 10, so that uh, sum is 18, max sum is 0. How is it even possible? Like we are updating the max every time. It is going to be t of I actually. And but why the sum is, yeah, sum is 18? Let's, why is this thing working or not? Max sum. Let's try now. So it's going to be a sum not answer. We are getting answer as 64. Oh my god. How is it is possible? 18 plus 4 is going to be 12. 12 into 4 is going to be a 48. I think it is also possible. 8 into 8 is also going to be 64. So Alice want to maximize the score if there is a multiple values of k that achieve the maximum score difference. So why it can't? Yeah, Alice take k as, we can say, 8. If Alice choose k as 8 and something like this, the very only 8 value is going to be 8 and the difference is going to be 0. Sorry, the difference going like value 8 and 0, the difference going to be 8, and k value is also going to be a 8. In that case, 8 into 8 is 64. I think it is a better answer. So yeah, so you can see like in that case the difference is 0. 468, the difference is 0. So if the difference is 0, difference is like yeah, difference is 0, like difference is 8 in this case, but if we choose 468, in that case also the difference is 8, but the value of the k is 2 only. So I think we have to maintain one more thing. So to achieve this thing, like we have to do something like what we can say, we can also make a prefix thing also. So let's make that, make like for loop int I equal to 0, I less than n I plus plus, and dp of I equal to dp of I minus 1 plus v of I. If I equal to 0, we can say that dp of I comma is equal to v of I, and we can simply continue in this case, and we can declare a vector int dp of n comma 0. Yeah, we can simply declare this array also, and after that what we can say, we can also calculate this thing on a single time also. Let me do this single time only, and after that if this thing is calculated, then we have to make a prefix for this also. Yeah, so it is going to be a calculate this like overall total for that. Yeah, now we have to maintain here the start and end, like at what point the start and end are, like initially the start is going to be a 0 and end is going to be a 0 as well. And if this is that, this if the value is going to be a 0, start is going to be a I plus 1, and end is going to be also I plus 1. Else and is going to be a, and is going to be a I. And if this sum is greater than max sum, like if the if the sum is greater than max sum, we can say yeah, max sum is going to be a sum. So we can simply track, like yeah, start and end will be a tracked over. So like at what subarray we are starting and what subarray we are ending. So in that case, the we are going to calculate our difference. Difference is going to be a dp of and minus, like we are going to calculate that's the sub prefix like subarray which we are chosen, whose like total sum without the negative values. Like dp of and minus, we can say dp, like if the start is greater than 0, then it is going to be a dp of start minus 1, else it going to be a 0. So yeah, difference is going to be a, then we can say difference minus the max sum. Difference minus we can say max sum. Yeah. So if the temp answer is greater than, we can say like we have to maximize the difference. So we can say we can maximize the difference, like max difference initially is going to be a 0, and like if the difference is greater than, we can say max difference, it's going to be answer is going to be a, we can say yeah, temp answer in that case. So let's try to run this. So what are value of start and end? Start and so yeah, like we have to maintain the start and end, but we have to like calculate. We can simply calculate this difference like a total sum, or we can simply define difference here, and the difference initially is going to be 0, and the difference we can do the same thing inside this. So we can simply calculate difference here. So like we can only update difference if the value of this like sum is great, current sum is greater than max sum. So let's define the value of k, and the max sum we difference we get, and then we will check why we are getting wrong answer. For k equal to 2, we get difference as 0. Wow, that's insane. So let's define difference as 0. Difference as 0. So yeah, difference is going to be a total value minus the negative value. So negative value is going to decrease the value. So yeah, the Alice value is going to be this difference, and we can say like in total sum is going to be this. It is going to be a total sum. Like now, in difference is going to be a total sum, we can say total sum minus the max difference, but this max value is for the like we can say Alice. So actual difference is going to be a max sum minus difference. Sorry, we can say so Alice will gain, like Alice will gain the profit of, we can say, yeah, Alice will gain only max sum, no? So difference is going to be this max sum only. Comment हो जा रहे. How we can do this thing like so difference. So difference is going to be a like this sum like the max sum we get the subarray sum. So the subarray sum we get is like 18 in this case. So the max sum is 18 in this case. So difference is like we can say max sum. So what is the maximum difference we can get? 18. Yeah. So for 18 into 2 it is going to be a 16 only. Answer is going to be a temp answer into k, and k is going to be a 16 only. So we can see it is going to be a temp answer only. Again we are getting wrong. See you out. What are we are getting? Max sum. What is the max sum? Like we can say it like it is going to be max difference, and max sum is going to be a like a max difference is going to be a max sum. So I have like given a very we can say very bad variable name. So I have assigned. So it's also becoming difficult for me to debug also. So yeah, in this case we are getting 4. So difference for k equal to 2 is going to be a 3. So why maximum is 2? Maximum is going to be 3 only. You can say for auto it comma dpc or right. 2 3 5 we can say it is going to be deep, not dp, it is going to be t only. 2 minus 1 1. So what we are getting the sum plus equal to t of 5. Yeah, we don't need this total something on, not no at the moment. It is going to be like sum is going to be initially 2, then sum become 1, and then again sum become 3. So the max sum is going to be 3. Let me also write some. Initially the sum is 0 now. So initially sum is going to be 0 only. So yeah, we are getting -2, and like in case of negative value, we do something like plus mod, then modulo mod. So I don't think it is going to be work, and so yeah, let's give it a try, and then I will try to make it a better. Mm, I Yeah, we are getting wrong answer. Let's see. Output is 28 and expected is 361. So yeah, it is going to be a wrong only. This value is going to be 1,000. Anyway, let's try again. Yeah, I think it is going to be work. Let me remove all the console and make the code little bit cleaner, and then I will let's try to submit this now. So we are getting wrong answer for this thing. I think it's going to be a long like that thing mistake. So we don't need this TP thing. So let's remove this thing to make code look cleaner. And yeah, let's also remove this thing. And what are the other thing we are taking that we are not using? So yeah, let's now run this thing again. Hmm, I think it the so we can do mod at that point only. Yeah, like this point only. So let's try now. Again, we are getting wrong answer. 1e9 plus 7, 3, 3, 6, 7, 8. I think this is correct. But we can say like adding a more to a positive value will not give us something like a can say a wrong answer. Let's print the I have the value of answer and see like if it is a huge value or not. Then may possible like we are adding mod can give a so the answer is this negative value. So it is going to be a 5,000 I think. Now it should work. Yeah. So like you can see like the value is up to 10 is to power 6. So for that like 10 is to power 6 we have to achieve something like 3, 4, 5, 6 to achieve this thing. We have to do but yeah we can divide it by 10 square root of this thing. Square root of square root of 100, we can say 3 4 5 6. It is going to be 1,000 only. So why? So yeah, let's try to submit this thing and then check why getting again we are getting the wrong answer. So yeah, so there may be possibility like in the case of negative we are getting that like can we increase like a little bit value for that and then try to run this code. Again we are getting the wrong answer. Let's try to run it for 10 hours only, but I think it is going to give us a TLE. So yeah, you can see like in case of this we are getting this answer, the same answer which we are expecting. So what happen is like in case of negative we have to iterate the k value to that thing. But why like that? So this k is going to not going to be modulo any value. So v of I modulo k equal to 0. So what we can do further like, so I think like if we have something like value like this only 9999 something like this. If we do modulo wise something like we can say 3001. So yeah, it is not divisible. So it is going to be in a this thing only. A negative value, all values are going to be a negative. But there may be possibility like multiply by k can give us how it is going to give us a max difference. Max difference can be a max sum. So instead of max sum, it is going to be a max difference, and max difference, can this increase with the, so we can say what is the max sum, max sum we are getting. So let's, I think it is going to give us TLE, output limit exceed. So yeah, max sum is going to be a -1 only. Max sum is going to be a -1 only. Then -1 into k is going to be a as maximum as possible. So k can go up to 10 raised to power 6, I can say max. So let's see what is the maximum. Six. In this case, what is the maximum? So it is going to be 6. So what is the value? This is the value. So if we divide a number by a same number, like if the number is divisible by same number, then difference is going to be a 1. So answer can also be a we can simply check like this 1000 only, and then we can check like what is the max from whole range auto it comma we can say max into maxi value is going to be a int min, we can say 0 because it's a positive only. Max value equal to max of max value comma you can say it, and max value is going to be a something like that, and then can do like what is the k value is going to be only the maxi value, and the difference is going to be a maxi value only. Maxi value into maxi value modulo mod. Can this be a answer? Yeah, can we define this as a ll? So now let's make. Oof. Oh, what is this maxi value? Like we can make this as ll also. So in case of maxi, the value is going to be a 999983. So what is the maxi in this case? So what is maxi value? Maxi value. Let me remove this. So 999 4 times 9 83 4 times 9 83. See you out. We can say what is temp answer. What we can say max sum and k. So like max sum is going to be only 9999 this thing. But why max sum is greater? So like all the number are modulo by that are positive. Yeah, a number greater can also be something like that. How can we do this thing? What we can do? Like we have to check for every number. Like there may possibly like bigger number modulo also work because the number is of same type. So yeah. So what we can do for every number we can do something like some calculate. We can say like a value can be only up to we can say vector int dp of, but what if there may be a negative value as well inside between them? Like if there is a negative value between them, then there may be a possibility like we can't do anything. And there may be possibility that is some smaller number greater than equal to So we are left with the only one case where a single value can give us a maximum, we can say maximum sum. A single value can contribute to answer greater than 3, we can say 3000. A greater than 3000 value, where the value can contribute to the answer and the answer is going to be maximum. So in that case, the first thing is like there may be some continuous subarray of that number, continuous block, or there may be possibility like we can say we have some other number as well in between. So if we can check for every number, then it's going to be like quite high, like 10 raised to power 9. But why we have to check for every number? Only the number are only up to 10 raised to power 3. So what we can do, we can check only for 10 raised to power like that different number only. So what if we can track that numbers? Like we can say vector entity. Yeah, we can say instead of vector, we are going to take a set of st for auto it comma v st dot insert, we can say it. Yeah. So yeah, we are going to do this thing for 0, we can say 2 to 10 is to power 3, we can say a little bit more than that, and then we can simply copy paste this thing, and we can do this for auto it equal to st. Yeah. And what is the k? I have defined it as a k, so kst, and then we can skip this thing, we can say yeah, yeah. Let me draw this now. Working for last thing, but again I yeah, we can say the if maximum is greater than difference, there we maximum is greater than difference. What is maximum we have defined where? Like if the answer is firstly we get the max answer, why we are getting the lower answer then again? Max difference. So let me print here a max sum comma answer. Oh, sorry. It is going to be a max difference. The maximum is a local variable. So yeah, So how the max sum is 19? See out max sum. We can say max sum comma k. Let me print like for what k value the answer is 19 because the max sum can't be a 19. K is 8, like max sum is 8 and the k is 8. So how the max sum is greater than like, so yeah, we can skip this condition like if it is less than, we can say equal to 1, we can simply continue. Let me submit this thing now. So yeah, now it's working. So let me remove this different consoles. Yeah, that I have used. So yeah, now it's working. So let's try to submit again. Does there is any log now? No need for declaring a vector every time. And can we do some more optimizations? Like we can simply like we can end. So no need for this T also. Nice. By removing this, the size increase, the time increases. So let's try to submit it now and let's see. So yeah, now it's working. So let's see why it is showing us an error. I think it should work now. So yeah, it's working. So let's take a small break, and after that, I will explain my thought process how like how was all this thing. So yeah, we can say. So yeah, let me explain this now, and then after that, I will stop this video. So so the first main idea like is that like any number can, like if there are multiple number that form us the answer. So that must be like something like that must be divisible then, like if the number are up to 10 to the power 6 like this. So like a common number that can divide two or more number can be up to 10 to the power 3 only. So because like if some number is greater than then like we can say like something like that number, this, then multiply by this is going to be greater than that only, like it is going to be 10 raised to power 8. So there is only one number that is divisible by that number only. So that's the main idea. So so like so to solve like to check for that, like as the number are very small, like 10 raised to power 3 only, and again we are doing this for 10 raised to power 3 only. So why we are doing it for 10 raised to power 4? That's why it is just giving a TLE. So it's going to be something like that. So yeah, so it's going to be a 10 raised to power up to 3. Then what we are doing, we are simply, let's say we have something like 4, 6, 8, 3, 2, 1. So let's say the number is divisible, we are taking number divisible by 2. So it's going to become something like, yeah, this is going to be divisible. Then it become like positive. Then also this positive. This is also going to be positive. But like this number is not divisible by 2, and let's say this is 4. So this become negative. So this become minus 3, and this become like positive 2 is divisible by 2, and 4 is also divisible by 2. It become 4. So you can see like we have to find the maximum subarray, like maximum subarray sum greater than equal to like maximum subarray sum. So why we need maximum subarray sum? You can see we have to maximize the difference, like maximize the difference between Alice and the Bob. So to maximize the difference between the Alice and the Bob, so Alice is going to make its answer as much greater as possible. So to make the answer greater from some sub, we have some subarray. From subarray we can choose some value, some like some array we can choose some subarray, and that and we want subarray whose value is going to be maximum. So you can see this is simply a so in this we are needing a maximum subarray sum. Yeah, so we are calculating the maximum sub, like we are making this perfect sum, and yeah, we are adding like vi value to be like if it is modulo by k, then we are going to be a positive value, else it is going to be negative. Then we are simply doing like simply a cadence algorithm to find a maximum, like a maximum difference. And after that we are checking like we also not need this difference anymore. I think there is no need of this thing also. So yeah, so we don't need some this thing and we only need like a temp like max. What is the max sum? Like if the max sum is this is actually a max difference, I name it as the max sum. So max difference is like a max difference is greater than the previous max difference, then we are updating our answer, because we have to maximize the score, not the answer. So we have to return the answer for the maximum score, like a maximum difference. So yeah, we are maximizing this difference and storing answer as this. So as I am taking the answer as LL, so I am simply modeling it as N. So for the negative value, if we have something like -4. So firstly we are making add something like it's a mod value, and then we are doing modulo, so that the answer remain positive. So yeah, and like same thing I am doing for the k, like there like I have solved for the multiple value case, like where the some number is usual like something like that. So let's say we have something last number like 999,876. So it this number is not divisible by any other number, like this number is going to be divisible by itself only. So like up to 3,000 we can say 3,000 or 1,000. This number like no number can divide this number include like excluding itself. So yeah, what we are doing, so like we are checking for every number, like so we are checking for every number the same thing, to assuming that this is a k. So this will solve like handle our case where where the single value can like give us an answer. So yeah, that's it for the problem. So yeah, I think it's enough for today. So yeah, let's stop this stream. So I hope you enjoy this video.